Okay, on number 8 in section 4.7, it looks like they're asking for what is the maximum area of a rectangle inscribed in a right triangle with 5 and 8. And this problem is like, okay, with 5 and 8, as in figure 10, I don't really know if they mean that those are, when they tell you the sides of the rectangle are parallel to the legs of the triangle, they don't tell you exactly that those are the measure of the legs of the triangle, but that is what I'm going to hypothesize. So I don't know if that's actually correct or not. I drew that picture kind of the opposite direction, but to me, I think they're saying that this whole length right here is 5, and that this whole length right here is 8. So you know the formula for area of a rectangle is length times width, or x times y, if you wanted to think of this as your x and this is your y. And so what you would like is to have to kind of come up with a way to describe this length right here, y. Well, if you think of this as, if you think of this triangle on the coordinate system with 5, 0, 1, 2, 3, 4, 5, 6, 7, 8, 0, if you think of the right triangle that way, well, you can get the equation of this line. The equation of that line is negative 8/5 x plus 8, because it has a slope of negative 8/5 and it has a y-intercept of 8. And so then you can plug that in to this equation. And so the area can just be described in terms of x as x times negative 8/5 x plus 8. And then this is just a quadratic that you can optimize. So a is equal to negative 8/5 x squared plus 8x. Taking your derivative, you get negative 16/5 x plus 8. You set that equal to 0. You get x equals negative 8, and then times negative 5/16, because you flip and multiply. And cancel here, and so we get x equals positive 5/2. And then to compute, to verify that that is a minimum, you look at the second derivative, and you would get just negative 16, that is a maximum. You get negative 16/5, which is always negative, so that function is always concave down, which implies that the critical number, the critical point from your first derivative, has to be a maximum if it's concave down there. So we have that x equals 5/2 is a max. And they want the maximum area, so you're going to do 5/2 times, go ahead and compute the area. So area is going to be 5/2 times negative 8/5 times 5/2 plus 8. And so the 5's cancel here. That's negative 4 plus 8, which is 4. So that is 20/2, which is 10 units squared, or square units. Okay, so that one's tricky. I think that's what the author meant with his notation. Hopefully it is. Anyway, good enough.